All right, let's say you've got a room that is 9 by 12, okay, rectangular room. You're going to place inside that room an area rug. So we're going to sketch out a possible area rug. Now this should look similar to ones we've done before when we're finding the area of the border, but this time the border is not given. I want the border here that we've created all around the room. That is going to be our unknown. Okay, our border is going to be X. So we'll have X here, it'll be X from here to here, all around, and X from here to here. So we need to find a way to represent the length and width of this rug inside the room. Now, one more thing that we're going to be given here is the area of the rug is going to be half the area of the room. So this is the information that's given to you. We're going to write an equation to represent the situation, but we'll have to solve it using factoring, okay, as we did at the end of the last chapter. So we know that we have a 9 by 12 room. We have an area rug inside that is half the area of the room, and the border that the rug leaves behind is X, and that's what we need to find. Okay, so we're going to use this then to help us write our equation. So we have to find the area of the rug, or find a way to represent it, and set it equal to half the area of the room. That we can find. The area of the room would be 12 times 9. We need to find a way to represent the area of the rug. So we've got the length here. Keep in mind that the entire length from here to here is 12, so that is including this outside border. So if from here to here is 12, we only want the distance from here to here. So we need to take that border away from this end and from this end. That's taking X away from each side. So we have 12, which is the entire length. Take away 2 X's, 1 X from each side. And then the width right here, the entire thing is 9. And again, just to get from here to here, you need to take the border away, but from each side. So here we have 9 minus 2x from here to here. So that's how you can represent length and width of the area rug in the middle of the room. So the area of the rug can be represented as 12 minus 2x times the width, which is 9 minus 2x. And that equals half the area of the room. And the area of the room is 12 by 9. So we can actually figure that amount out. And so this is just an equation we need to solve. So we'll FOIL out on this side. And we'll have 108 minus 24x minus 18x. Plus, now we're going to have a squared term here, positive 4x squared. And if we multiply this out here, we will end up getting 54. So we can clean that equation up. When we are solving, because our x squared term is not going to disappear, we want to set it equal to 0. So I'm going to go ahead and bring the 54 over to have a 0 over here, which means I need to subtract it over here as well. And I think I'll rearrange my order. I'll put my 4x squared first. We'll get it in standard form. Let's combine our like terms here, and that'll be a negative 42x. And then now my constant, which was a 108, if I subtract that 54, it is now a 54. So this is the point where we now solve by factoring. We have a trinomial here with a coefficient at the beginning and a constant at the end. But if you notice, all three numbers here, if you want to make your values more simple, all three numbers have a 2 in common. You could start by factoring a 2 out, to get smaller numbers to work with. So if you do that, pulling out a GCF, you'll end up with 2x squared minus 21x plus 27. Makes it a little bit easier to work with. So now you need to take your factors of 2 and 27. You are trying to get a negative 21. So the 2, we only have that combination to work with. And 27, now granted you do have 1 times 27 to think about. Otherwise it's just a 9 times 3. And I'm going to go ahead and try this combination first. See if we can pair those up in a way to get a negative 21. Okay. The way I have it written, if I go ahead and multiply up and down, 1 times 3 will get me 3, 2 times 9 will get me 18. Foiling out, these two would be my middle term. I can make that a negative 21 if they are both negatives. So I need to pay attention to who went together here. The 1 with the 3 and the 2 with the 9. Those are the numbers that will get placed inside when you factor. So if I place my 1 and my 2 first, they go in the first spots of each set. I'll go with the 2x here, the 1x here. So I've made the 2 an outer, and that's my inner. So my outers need to get multiplied together, and that's what I linked together over here. These are my outers because there is the 2 that I placed inside. So 2 times 9, that will get me my negative 18. So in order to multiply the 2 by a 9, I need it to be the other outer value. And when we multiply, we want it to be a negative 18. The 1 is an inner, so the 1 here got multiplied by the 3, so the 3 must be my other inner value. When I multiply, I want a negative 3. So we have factored that, and that's from our last chapter. So using the zero product property, I look at all of my factors here. I have a 2, a 2x minus 3, and a 1x minus 9. Using all the ones that contain a variable, either of these factors could be my 0 if we're multiplying to get a 0. So either 2x minus 3 could represent my 0 value, or x minus 9 could represent my 0 value. So here if I add 3, I have 2x equals 3, and x would equal 3 halves, or 1.5. Here x is going to be a 9. Now with a word problem, you need to think about what the variable is representing. So let's go back and look at our diagram. All right, the variable is representing our border. We would also plug it in here to find the length and width of the area rug in the middle. One of our values was a 9 for x. So if we choose 9 as x, see if that would make sense. That means our border would be 9 meters. That doesn't make sense because the entire room is 9 meters wide. And if you plug in a 9 into the area rug here for length and width, you'll end up getting negative values. So with word problems, there are times where you'll throw out one of the values that you got for your variable. I believe we're going to throw that one out. So in this case, x would be a 1.5. So the area of the border is 1.5 meters. So pay attention to what your variable is representing. You do not always use every x value. All right, on this one, you're going to throw a ball in the air. When you throw a ball in the air, this is the path it would take. Okay, the ball goes up, it hits a high point, the ball comes down. Now, on your worksheet, you're going to be given some equations that you can use for this type of problem. Okay, the rate of the ball is 24.5, okay, meters per second. The height of the ball is 19.6 meters. they want to know at what time will the ball reach that height. If this is how fast the ball is going, this is the height they want the ball, they want to know what time that will be. Now, they're giving you a couple of values to choose from. One gives you an equation that is in meters. One gives you an equation when the height is in feet. This is the one that you will use, and it's on your worksheet when you're dealing with meters. The height of the ball equals the rate times time minus 4.9 t squared. So you need to pick which of the two equations they give you to use. Pay attention to your unit, meters or feet. And then now you just plug in. Now think about it. When you're throwing a ball, it's going to reach a height on the way up, and it's going to reach a height on the way down, the same height. So there is a possibility you could have two answers. If you get only one answer, it reaches a height only one time, that is your peak. It reaches your highest point if you have only one value for t. So we can find out if that's our highest point or not. All right, so using this formula, our height is 19.6. The rate is 24.5. And our time is what is missing, minus 4.9 t squared. Now what I'm going to do, I always like my squared term to be positive, and I do want to have it set equal to 0 when you are solving. This is called a quadratic equation.
Good morning, teachers and staff.
So we want to make sure everything is set equal to 0, but it's nice when your squared term is positive. So I'm going to move that over to the other side, and I'll move that over to the other side. So I'll add the 4.9 t squared, and that's a positive, so I'll subtract 24.5 t. So all of that will be added on this side and then subtracted. So your equation now will have 4.9 t squared. I'm going to have this be at the end, minus 24.5 t, and then this positive 19.6 will stay there. But now we are set equal to 0. So I just moved everything over to the left side. When you have a problem like this, what I want you to try to do is whatever this coefficient is, factor that out. Factor it out of all the terms and see what happens. If you factor a 4.9 out, you will be left with t squared, and when you divide 24.5 by 4.9, you're going to end up with minus 5t, and when you divide this by 4.9, you end up with a 4. So you've got a much nicer trinomial that you're dealing with. So when you get to these problems here, and you get your equation, factor out whatever that coefficient is. Much easier to work with. All right, so we're at the factoring point now. We need to factor this trinomial. And we need to take factors of 4, trying to get a negative 5. So if we do that, the only ones we have to deal with are 1, 4, and 2 times 2. This combination here can get us a 5, and if they are both negatives, it can get us a negative 5. So we'll place the t's in the first spot, and then one will be a minus 1, the other is a minus 4. When you don't have a coefficient here, something other than a 1, you don't have to worry about that value. It's only the 4 you break down. You have 3 factors now. You only need to worry about the factors that contain a variable, which would be this one and this one. So each one of those could be your 0, using the zero product property. So when you solve each of these, t would be a 1, and t would be a positive 4. So again, think about what's happening. You're throwing the ball in the air. That means 1 second after throwing the ball, it's hitting 19.6 meters, hits its high point, comes back down, hits that same height again on the way down. That's why you have 2 times. So your times would be 1 second and 4 seconds. And that's what they're looking for in that particular problem. Now, if they ever give you a problem where it says, what time does the ball hit the ground? Well, the ground would be here. If you throw the ball, it hits the ground here. Think about what your height would be. Your height would be 0 if the ball hits the ground. So they may not give you a height. They're wanting you to figure out that h would be 0 if they're telling you it hits the ground. So they'll give you the height in different ways. They might give it to you outright or give it to you in a way where you need to think about what the height would be. All right, let's try one more. Let's do a consecutive integer problem. Let's find two consecutive negative integers. Whose product is 90. Two consecutive negative integers whose product is 90. So let's think about how to set up our two integers. Your first one will always be x. Now they don't say if it's even or odd because that's when you count by twos. They just tell us it's negative, so we'll keep that in mind, but we don't deal with that while we're working on the problem right away. We just want consecutive. That means one after another, so we have x plus 1 for our next one. Their product is 90, so you're going to multiply the two together. Oh, not 90, their product is 90. All right, and that would equal 90 there. So that's your equation. We need to solve it. So again, we just know the zero product property at this point. So we'll distribute. We need to set it equal to 0. Okay, that means I want to bring my 90 over, so I'll subtract 90. If we write it in standard form, we have x squared plus x minus 90. Again, so we know we're solving by factoring. So we need to find factors of 90 to get a 1. So if we break down a 90, and it's a negative 90, okay, so we need one positive number, one negative number, and we want to get a 1. So if I take a 9 times 10, if I make the 10 positive and the 9 negative, they will add to get a positive 1, and they multiply to get a negative 90. So that looks like a combination that's going to work. So if I put my x's in, so when I FOIL, I get x squared. One will be a minus 9, the other will be a plus 10. I am multiplying two values and getting 0, so one of these factors must be my 0. So either the x minus 9 is going to be my 0, or the x plus 10 is going to be my 0. This would get me a 9. Subtract 10 for this one, and I would get a negative 10. So these are both correct answers to this equation, but again, go back, since it's a word problem, you need to make sure that the answer you choose fits what's going on in the word problem. I want two consecutive negative integers. This is now where you come in with the negative. This one's positive. So yes, it is a value that will work in this equation, but it doesn't meet the requirement of being negative. So we are going to use negative 10 as our x value. So we want to know what both integers are. So this value will be a negative 10, and if I take negative 10 plus 1, my next integer will be a negative 9. So I just took the one x value that worked, which is this one right here, and then plug that value into the setup to see what the two integers are. So here you'll be working with different kinds of word problems, and you know that you'll have to solve your quadratic equation using factoring.